Kia ora. Thank you very much for joining us. When Alison, the person that organizes these events for Catalyst, asked me, Bruno, what will be the topic for the next cloud event? I thought about it and spent a couple of days thinking what would be useful for us to talk about. And every time we do these events, we talk about the exciting new features, right? We talk about the new things that happen, the new features we introduce, the new things you can do with cloud computing. But I have then realized that we had, there were some very important cloud incidents recently, some of them affecting companies in our region, some of them affecting companies in the United States, and I'm sure we all have noticed them. So I thought, it seems to me, talking about disaster recovery and business continuity on the Catalyst Cloud, on the cloud, including the Catalyst Cloud, would be appropriate. Now, before we do so, these events are also an opportunity for us to celebrate a few achievements. And one of them is you all being here. A lot of you are currently customers of the Catalyst Cloud, and we're certainly happy to be here serving your businesses with cloud computing. We have recently achieved something close to 400 projects hosted on the Catalyst Cloud. In there you will find everything from small startups experimenting with ideas to large enterprise and telcos. You will find people running payroll systems on our cloud, billing systems. You will also find most government agencies currently consuming cloud services from us when they need cloud computing capabilities onshore. The other thing is, in the audience, we have some of our cloud engineers and people that are part of the cloud team. And I just would like to acknowledge and say thank you for all your hard work, because the Catalyst Cloud wouldn't be a reality without you all. So thank you very much. Moving on to the actual topic of the presentation, from time to time the cloud breaks, right? And I'm not talking specifically about a cloud vendor here. This can happen to anyone. So one morning I woke up and I was shocked when I saw the headlines on stuff saying that a cloud accounting company, Xero, says it didn't know it was entirely reliant on a United States storage facility until it crashed, right? To be honest, I don't believe it's true. I think Xero has got some very competent engineers there, but the reality was it did affect their services. So I thought, okay, why don't we investigate a little bit these cloud incidents? Because what I can see is that we are all making a mistake when using cloud computing. Very often we don't understand a concept that, if understood correctly, would potentially avoid incidents like this. The second thing is, there's this interesting tweet from a guy called Travis, and he was saying that the moment you realize half of your infrastructure relies on a cloud service, including your maintenance page. So the interesting thing about this one, and here's the first lesson that we can learn together, is we are all using cloud infrastructure, but we are also using software as a service offerings as our monitoring systems, as our, let's say, status page, so we can communicate to customers that an event happened to our services and we'll be back soon. But one thing we often don't do is to ask our software as a service providers, what is the underlying infrastructure that you're using to provide that service to me? Because it's important for us to understand that if my monitoring system that I use to troubleshoot my services online are actually exactly on the same cloud region where my production system is, both of them can go down at the same time. And that's not a good place to be. So there is something really interesting that New Zealand has done. I don't know how many of you have heard about the Cloud Code of Practice in New Zealand. 3 maybe.
Say again?
Cloud Code of Practice. So that's an initiative from the Institute of IT Professionals in New Zealand. A bunch of companies came together to discuss what are the good practices when using cloud computing. And that became a set of disclosures, a document that, as a cloud provider, as the provider of either infrastructure as a service or software as a service, I'll fill in and I'll describe to you, when providing this software as a service solution to you, I'm using this infrastructure, servers located in this region, this is how I do my disaster recovery, this is how I back up my services. So this is the kind of information we need to make informed decisions, appropriate decisions about our SaaS vendors and the relationship they have to the infrastructure we are running. Now, before we talk about the next topic, I just need to make sure that we are on the same page when it comes to a concept called failure domains. And it's very easy, so let's just do a quick exercise here. If as a cloud customer you handle me a piece of data and I tell you that your data is stored in this disk, what is your failure domain in this case? It's your disk, right? If that disk fails, then your data is unavailable. Now, if I tell you that I have replicated your data and it's in these two disks inside the same server, because these two disks are unlikely to fail at the same time, you will probably tell me the failure domain is the server now. If that server is not available, then my data is unavailable, and that's correct. Two servers in the same rack. If that rack is affected by an incident, like a localized power outage that takes down that rack, now that's your failure domain. Two racks inside the same data center, maybe in different locations. Now your data center is your failure domain, right? Very easy to understand. So the reason I wanted to look at that is because there is this concept called a cloud region and availability zones. And this concept is often misunderstood. And this happens with our customers too, and it's something that is important for us to understand. So an availability zone is a segment of a region that cloud providers use to create a failure domain for you, to isolate a failure domain, right? And why is this important? This is really important for high availability. So for example, if you have a database system, a database technology that allows you to launch two database instances and cluster them, you don't want them to end up in the same physical server or the same rack, for example, and be subject to an incident that takes both of them down at the same time. So by segmenting our regions with the concept of availability zones, we give you the ability to create high availability clusters inside that region. And for some businesses, that segmentation may be enough for their DR plans. For most, they are not. The other important thing to consider is that the way cloud providers implement these availability zones will vary. Some cloud providers will actually have 2 or 3 data centers very close to each other, but connected to different power, different networks. Some data centers will have a big data center. Some cloud providers will have a big data center with multiple rooms inside that data center, also with different power feeds. So there are multiple ways you can implement this. But the important thing for us to keep in mind is that the cloud region is a failure domain too. Cloud regions do go down, and we have seen that happening to pretty much every cloud provider. So here's an example. Some of you may remember the 5th of June last year when a severe storm hit Sydney, and it affected the availability zone of a cloud provider there. And what happened was, because we are all doing high availability between these availability zones, when the first availability zone went down, everyone started migrating their workloads to the second availability zone. And that movement overloaded the control plane of the region or of that secondary availability zone. And we saw a lot of people on Twitter saying, well, I'm trying to connect to the cloud dashboard here and restart my applications on the secondary availability zone, but I cannot. That action is not working, right? And that's the point where you have a region being affected by an incident, and you would trigger your disaster recovery plan, which ideally would move your workloads to another region, to an alternative region, right? There were also 2 recent storage incidents that took cloud regions down for cloud providers. When you're dealing with object storage, for example, it's very common that object storage will replicate its data across availability zones inside that region. But if you release a bug that affects the object storage system in all availability zones at the same time, then your storage system is down. And to be honest, these 2 incidents, they happened very close to each other. You had one cloud provider having them, and I think a week or 2 weeks later, another cloud provider had a very similar incident. So the important thing is, if you've been doing cloud computing for a while, you will probably remember the phrase design for failure. We have used this as a mantra in the beginning of cloud computing. If you don't believe on Murphy's Law that says anything that can go wrong will go wrong, at least look at what cloud providers are telling us. If you look at Microsoft Chief's reliability strategies, he's saying cloud service failure is inevitable. If you look at Amazon Web Services, they have this really interesting document called Architecting for the Cloud Best Practices. I really like that document, and I would highly recommend you to read the 2011 version of that document. The 2011 version was written by engineers for engineers. It won't spare words to explain to you, this is how this works and this is what you would do in a situation like this. Whereas the more recent version of that document is full of sales and marketing terms. So the old one is better. Now, some people ask me, okay, why this company or that company was not affected by this specific cloud incident? And in this case, I'll use Netflix as an example because I think we all know how they are pushing cloud technology and raising the bar in terms of how cloud computing can be used. And I'm sure that a lot of us use them as an example of what can be achieved with cloud computing. So if you go to the Netflix technology blog, you see that they are talking about doing active-active for multi-regional resiliency. So they are running their systems across multiple cloud regions. In fact, I was reading another article from Netflix, and I've learned that they are using 12 global regions to serve their customers. And if one of these regions go down, they use their global load balancer to direct customers to the nearest location that is still healthy. So yes, things may get a bit slow, or the error rate may increase, but they are still serving their customers, right? So this is why they haven't gone down. And because one of the recent incidents we had is related to object storage, I thought it would be a good opportunity for us to look at object storage in depth and understand how it works. So some of you may not be familiar with object storage. Block storage is what we've been using for many years in the IT industry. It's the place where you store your database, your transactional data, right? When you're talking to block storage, you're using protocols like SCSI, for example, and you're talking about, please give me this block. I want to read the data contained in this block. Whereas object storage is modern storage that was created for web applications. It was created for the internet. And as such, it talks internet protocols. You use HTTP to upload or download objects from your object storage. And an object is no longer just a piece of data contained in a block. It will have the data as well as the metadata about that object. So for example, the things you would store in object storage, a video, if you look at YouTube videos, for example, right, you have a large video file, but you also have the metadata about that video. When was it produced? Any copyright that applies to that video. Here is also a very good place for big data. So we have scientists using object storage for their radio astronomy data, for example, or for bioinformaticians storing all their gene sequencing data in object storage. So the way object storage works is really interesting. When you go to an object storage system and you say, here's an object, I would like you to store it for me, it will use a pseudo-random algorithm that it uses a hashing algorithm that will translate the name of that object into a number, and based on that number, it will define where the copies of this object should be placed. So most object storage systems, it's very common for object storage systems to store 3 replicas of your data. And what we can do as your cloud provider when configuring this system is to say, please don't replicate this data inside the same disk, inside the same server, inside the same rack row, or data center, for example. Right? So we are, that concept of failure domains, we're defining the failure domains for the storage system, and we're asking the storage system that provided with these failure domains, increase the resiliency of the data. Try to keep it as healthy as you can. That's why we say that these storage systems are self-healing and self-managing. They are constantly inspecting the objects you store in there. And because we have 3 copies, we can say, okay, I can see that this one is incorrect. Maybe there is a single bit that is incorrect on this copy of the data, and rebuild that data based on the other 2 healthy copies. Now I'll be a bit more specific about the Catalyst Cloud because I want to use this as an example for this one. We now have 3 regions in New Zealand: Wellington, Hamilton, and Porirua. And what we've done with our object storage system is really interesting. By the way, this is the type of hardware that we use for the Catalyst Cloud. We have a preference for something called Open Compute hardware. If you haven't seen Open Compute, Open Compute is an initiative that was created by Facebook when Facebook decided they would open source the design of their data centers and their hardware. And since then, a bunch of hardware vendors and cloud providers joined that initiative and started sharing their designs and producing and consuming that hardware as well. So with our object storage system, when you have an object and you upload it to one of our regions, say you have uploaded that to the Hamilton region, initially we'll create 2 other copies of that object, so now we have 3 replicas. We'll go back to you and we'll acknowledge we have received that data. So at that point, you have your data within one of our regions in 3 different servers. Now, this is where most cloud providers stop. They copy the data inside that region to different availability zones or their own failure domains. What we decided we would do is that now behind the scenes asynchronously, we'll move 1 copy of your object to another region, 1 copy of your object to the other region. And you may ask me, what happens if this data hasn't been replicated yet to the Porirua region and I have a request going there? The object storage system is smart enough to say, well, I still have connectivity to Wellington and Hamilton. I can see I have the data in both of them, and it will proxy your request to one of them, serve the request, and then fetch the data and store it locally, right? Now, it is also possible to achieve the same thing with other cloud providers. And this is one of the reasons why the object storage incident hasn't affected Netflix. With some cloud providers, you may need to write your own application to do this form of replication. So you're constantly reading a storage bucket or container in one region and copying data to another. But other cloud providers, I'm aware that, for example, with Amazon AWS, you can go to one of your S3 buckets, and there is an option there that allows you to say, replicate this bucket asynchronously to another region, right? But it's important for us to know that this is not enabled by default, and when you do that replication, you're actually paying for the object in both locations, so that might double or triple your object storage costs, depending on how you do it. So with that, I just want to conclude by sharing with you something that I found fascinating. I've learned about this recently. Do any of you know what this is? This is a data center that is being built in Norway called the Lifdown Mine Data Center. So that's the data center in proportion to some objects that we're familiar with. And they are building this to be one of the largest, if not the largest data center in the world. They are talking about 120,000 square meters, 200 megawatts of energy going there. So it's a really interesting collaboration between the private sector and the government in Norway, where the government is, of course, providing them with some incentives. And what they are trying to achieve together there is to turn Norway into a data haven for big data analysis, cloud computing providers, and people that are computing at scale. The reason I find this interesting is a lot of people ask me, Bruno, why do you believe that having a cloud computing capability in New Zealand is important? And if, like me, you believe that we are now in the information age and that this transformation or mining of data into information is something that generates a lot of wealth and benefits for our economy, you will understand what is going on behind my mind when I think having a cloud in New Zealand is important. If you compare New Zealand to Norway, for example, you see that we have a lot of things in common. In Norway, they are using the cold air that they have naturally to cool down their data centers and achieve certain price points that other people can't. They are also talking about how energy efficient they are and of course the renewable energy sources that they have in that country compared to other countries, right? And when you think about New Zealand, we have a lot of that here too. So when we started the cloud project more than 4 years ago now, when we started the research and development, I remember that in the middle of it, a paper from our Commerce Commission in New Zealand came out saying that it would be impossible for New Zealand to produce cloud services that would compete in price with what was happening in other countries. And they were saying that's because the New Zealand economy and the size of the country is too small for that. 6 months later, the Catalyst Cloud went live, and our prices were comparable to what Amazon AWS were charging in Sydney. So if there's one thing that I have learned on the last 3-4 years, is that we should never underestimate the people of New Zealand and what they can achieve together. So that's me for today. Thank you.